Did you miss your deadline to renew your Medicaid coverage? You can still send your completed annual review form to Healthy Connections Medicaid. You may be assigned to another health plan, but you can ask to come back to First Choice within 60 days of renewed Medicaid eligibility. It's your family. It's your choice. First Choice is the right choice. Renew and choose us. Visit selecthealthofsc.com/renew to learn more.
Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Hi there, thanks for joining us. This is Space Nuts. My name is Andrew Dunkley. It's great to have your company once again for episode 367. Count them. 1, 2, 3. I'll come back later. But today on the program, we are going to be looking at the epic fail of Lunar-25, the Russian probe that went to the moon and decided that it would visit too quickly. We will also be talking about the reasons why there seems to be this race to the moon, because there are other nations up there already, including India. We're also going to investigate a new dark energy theory. This is rather fascinating and a bit close to home too. Plenty more coming up, including some questions about the end of the world. Yep, someone wants us to list the top 5 things that are likely to bump us all off. Gee, thanks. There's another question about light. We had a couple last week and they continue to want to know more, so we'll look into that. And another question from a female listener asking about Vera Rubin. We'll tackle all of that today on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And to discuss all of that and more is Professor Fred Watson, astronomer at large. Hi, Fred.
Hello, Andrew. Hello. Fancy seeing you here.
Yes, it's an unusual place for us to meet up.
To meet, yes.
Yes,
I actually went through your fair city on, what day? Saturday. But,
why didn't you come and help me move?
Well,
we had a lot of packing to do.
I was very pushed for time. I was driving from Canberra to Coonabarabran for the party for the 50th birthday of the UK Schmidt telescope. Which was
wonderful.
Saturday.
Yeah, I remember that. Yeah. I think we did a story on it on the radio recently.
Good. Yeah. Yes. So it's 50 years since it was inaugurated in August 1973. And we had a very nice time. And we're joined by some former Schmitters from overseas by Zoom. So we had a good session.
Yeah, fantastic. How does it make you feel when all these things are starting to hit half centuries?
Well, I'm considerably older than their half century, so it didn't really make me feel anything different from what I'm normally feeling.
Well, what can you do about it? I mean,
yeah, you can celebrate it. That's what I mean.
Indeed. Okay, well, that's good. We just packed some more and packed a bit more than that. Only a short time now before we make the leap. I'm glad it's only across town and not halfway across the state. Done a couple of those over my life. But
Try one country to another.
Oh, yeah. No, I've never done that. Don't want to do that. Unless there's a good offer on the table.
Well, there might be. Yeah, that's what brought me here.
Well,
twice, in fact.
Yeah. All right, let's get down to business, and we'll have a look at this recent fail by Roscosmos, the Lunar-25 probe, which went into orbit recently, decided it didn't like being in orbit and went into some kind of spiral crash into the lunar surface. Do we know what went wrong yet?
Only marginally. So this is Lunar-25. Do you know when Lunar-24 flew?
1976?
Yeah, 76, 47 years ago.
I read it a couple of days ago.
Yeah, no, we all did, I guess. But it's amazing, isn't it? It's that's how long it has been since a spacecraft in this series, which was formerly, of course, operated by the Soviet Union, has been launched. Now, Lunar-24 was successful, but nobody can say that this one has been.
Well, maybe they should have checked the batteries on Lunar-25.
Yeah, that's right. They expired in 1978. That's why there was a problem. One other factoid that you might be interested to know before I try and answer your question. Do you know what surprised me was how much stuff we have put on the moon? So this crash represents the 87th mission that has landed or crashed on the moon.
Is that true?
It's astonishing. Yeah, it's absolutely amazing. 87 of them, 86 until the day before yesterday, now 87. So that's right. Many of which were soft landings and successful missions, particularly the 6 Apollo landings, but some of the others weren't. Some were intentional crashes, some weren't, like Lunar-25. So what happened? Well, the best detail we have comes from one of the great names in contemporary space watching, and that is Jonathan McDowell, who is an avid, I think he works for NASA actually, but he's an avid watcher of all things space. And he has information that gives details of the orbit that the spacecraft was in before it crashed. And apparently, this is his thinking. If it started at 91 by 113 kilometers, what he means by that is a perilunar of 91 kilometers. In other words, its nearest point to the moon is 91 kilometers. Its furthest point is 113 kilometers. It's not far off a circular orbit, but like all orbits, it's elliptical. So that's the height above the surface. And he goes on to say, if it was heading for 18 by 100, 18 kilometers lowest point, 100 kilometers highest. And then it is thought that there was, I'm not quoting him here, but it's thought that there was a 50% excess in the braking rocket burn. That's the problem. So so what you've got to do if you want to bring it further down, and I think they were aiming for, as I said, 18 by 100 kilometers. That needs a required burn at the appropriate point in the orbit. But if you have 1.5 times that burn, then it will slow it even more. And the orbit that it was trying to go into was minus 15 kilometers by 100 kilometers. In other words, it was aiming for a perilunar point below the ground surface of the moon, 15 kilometers.
Right.
Yeah. So
that would do it.
Yeah, that would do it. That's right. This is conjecture on his part. He gives some other scenarios as well, but you can see that that's probably what happened. So we don't know why that 50% overburn or whatever it was why that happened. Software, perhaps.
Yeah.
Something went wrong in the engine itself. Didn't switch off when it should have done. Either way,
miles instead of kilometers.
Well,
because that happened once.
No, nobody had do that before.
No.
Yeah, I think that was.
Was it a Venus mission? Mars?
No, it's Mars Climate Orbiter.
That's right. Yeah.
Because there was a after the event there was an investigation, and it was by a body called the Mars. What was it? Mars Climate Orbiter Mission Failure Investigation Board, which is MCOMFIB. And MCOMFIB always sticks in my mind. And they looked into it, and I think that was the decisions, the ultimate outcome. Some were working in kilometers, some were working in miles. And I suspect it wasn't that, because I think it's a long time since the Russians have used miles. But it's, yes, basically something clearly went wrong. Apparently, the speed at which it hit the lunar surface, rather than being a few centimeters per second, was 1.68 kilometers per second. And that's enough to fry anything, really. Yes. So, yes, a sad end. Now, I guess what's interesting is what the Russians might do next. Because you have some insights into that.
Do I?
Well, you told me you'd read an article.
I have. What I found fascinating was that this particular mission was supposed to be partnered with ESA. And
yes, that's right.
because of the invasion of Ukraine, that partnership was dissolved. And so Roscosmos went it alone. And you've got to wonder if maybe that partnership, if it had stuck together, might have made the difference. Who knows? They also were supposed to take a rover to the moon, which they decided against at the last minute. So they didn't have the rover on board. Again, you wonder, well, did you change the parameters for the lack of payload, or, who knows? But so there were quite a few last minute changes to the mission. So I'm wondering if they were factors in its demise. But they are still planning Lunar-26 and Lunar-27. Which will carry the ExoMars rover, I'm guessing a prototype. So obviously Russia is looking towards Mars and using the moon as a stepping stone. And we've talked about that before because it's I think it's the South Polar region that they're all aiming at because of the water and the potential for creation of rocket fuel.
Yeah. Yes, certainly on the moon that's the case. Now, ExoMars is an ESA project.
Yeah, I know. It's maybe that's gone belly up as well. So
possibly. I mean, there's another part of that project which was Schiaparelli was a lander, and it was originally going to be jointly with the Russians. Am I remembering this correctly? Anyway. There was a breakup in the partnership between Roscosmos and ESA. They were also going to take other devices. Well, they did take other devices to the moon. They just slammed them into the surface. Spectrometers. They were going to study the soil. That's right. Yeah.
Look for surface water.
Very well equipped spacecraft. But I mean, there's been a lot of comparison with between Lunar-25 and Chandrayaan-3, which is, as we speak, it's in orbit around the moon. Took a month longer to get there because they didn't have the same kind of thrust at liftoff that the Russian spacecraft launch vehicle did. But there's been a lot of comparison between the two. So Chandrayaan-3 is probably a lot more like what Lunar-25 was planned to be. Before they ditched the lander. Chandrayaan will carry the Vikram lander, which has on board a rover, and that will hopefully rove on the lunar South Pole region. Certainly, Lunar-25 had more scientific instruments on board than Chandrayaan has, although it is still pretty well endowed with mass spectrometers and X-ray spectrometers and things like that. But you may have, your point is well made, Andrew, because if the rocket burn that was supposed to slow it down was made with the incorrect assumption that the spacecraft had more mass because it had a rover on board, then that would do the trick. That would exactly create what we saw.
And most people will say, well, how could they make that mistake? But you've got to remember this involves hundreds of people in different departments all doing their own thing. Yeah, and it could be as easy as somebody forgetting to send the email.
That's right.
I mean, it could be that.
Yeah.
We've got to also remember that Chandrayaan-2 also crashed.
It did.
Which was in 2019.
That's right. That was so did Chandrayaan-1, but that was intentional.
Yeah.
That was crashed out of orbit, and the idea was to see.
Well, you don't call it a crash then. If it was intentional, it was a hard landing.
Very hard indeed. So just going back to the facts and figures, very roughly, Chandrayaan-3 has twice the mass of Lunar-25. I think Lunar-25 is something like 1,800 kilograms, and Chandrayaan-3 is over 3,000. It's getting on for 4,000. So, and I guess that's because it's got a lander on board, it's got a rover on board, none of which was on Lunar-25. So yeah, it looks like it's a sad story of political consequences being felt down the chain in an organisation that, like all space agencies, is genuinely trying to achieve scientific results by putting things down on other worlds.
And the other thing I've read is that this was a keystone mission for Roscosmos. That they had a lot invested in this particular mission because it was going to make huge strides in their knowledge and probably to a certain degree their power and control over the resources of the moon. And they have recently announced that this is a new space race. We're going there because we want what's on that particular sphere. There's been talk about helium-3, which can provide a new type of power source. Everyone wants the water. There's a lot going on in terms of interest in the moon.
That's right. I read a piece which was very illuminating about the way Roscosmos feels about this, and perhaps the Russian media generally, which of course is tightly state-controlled. So the crash on the evening news on the day, one of the main state news channels, TV, the crash was the 8th item on the news and had just a few seconds of announcement. Yeah. Whereas there was a 4-minute session further up the news. It was on something like the availability of yak meat, so I can't remember what the details were. It was something a bit much more obscure.
It just shows how embarrassed they probably are.
I think that's the word. Yes, I think that's right. I think it's an embarrassment.
But I think the general feeling in the space science world is sympathy. No one's laughing at them.
No, that's right.
This has happened to everybody.
Yeah, it absolutely has. It is incredibly difficult to land things on the moon, and the South Pole is particularly difficult region. Yeah. So because you've got to, first of all, you've got to put the thing in an orbit that's virtually polar, which means you've got to shift the inclination of the spacecraft's trajectory by 90 degrees because it's coming in more or less equatorially. So yeah, it's a sad story.
To reconstruct an old joke, why didn't they make it out of the same material they used to make the black box?
That black stuff.
No, the black box in a
I know, yeah, that's right. They've got the black stuff. So what makes
it out of that, and it'll be fine. Yeah. Anyway, I don't think they'll give up. It's probably made them take an unfortunate leap backwards, but I don't think it'll be the end of their attempts to get on the moon, because it is becoming a pretty obvious that there are a lot of players who want to get to Mars. China is one, Russia is another, United States is another, and there'll probably be more than that. I mean, India is starting to become a real big player. Yeah. So we watch with interest. Do you have any faith in I think the water theory plays well for the creation of rocket fuel for a Mars mission. What about the helium-3 argument?
It's helium-3 is a sort of conjecture in a way. It's what you naturally expect when you get subatomic particles from the sun landing on a surface that's in a vacuum. I think I can't remember, it's a long time since I read up on helium-3, but I think there is evidence that it really is there, but it is probably highly diluted. It's something where you've got to, mine 25,000 tons of it to get some tiny amount. Yeah. But the thing about helium-3 is that it is potentially a clean nuclear fuel that you could put in a reactor the size of a microwave oven and leave it on your desk, because there's no intense radiation coming from it to speak of. Just one final postscript on this. Your conjecture about what the Russians might do next. Some of the things I've read suggest that there might be enough bits and pieces around to build another Lunar-25. Because a lot of these things are built so that you can test out the prototype, and you might have two of everything. It's common practice to have two of everything.
That'll be interesting.
Yeah.
So Lunar-25A.
What I read was 25B, but it might be.
Okay, well, that makes sense.
One or the other. I think that's what happened with with Insight. I think Insight was a spare Phoenix lander. Remember Phoenix landed near the North Pole of Mars, northern Arctic of Mars, and then Insight landed near the equator. But I think the basic spacecraft chassis, which is called the bus, usually, I think the bus was the same in both cases. One was a spare for the other, I think.
Wasn't Skylab Apollo 18?
I think that's right too. Okay. Yes, so
everybody does it.
We all do it. That's right.
Yeah, it's not a bad plan, actually.
Not at all.
We'll watch with interest. There'll be certainly more to see in the future in regard to Russia's attempts to get back to the moon. This is Space Nuts, Andrew Dunkley with Professor Fred. Let's take a quick break from the show to talk about our sponsor, NordVPN. Now, they are back on board with us, and we really do appreciate their support of Space Nuts. Now, what is NordVPN? Well, it's only the best virtual private network service available online, but they do more than that. And as a Space Nuts listener, you get a special deal if you sign up with NordVPN through the special URL, which is nordvpn.com/spacenuts. When you put that URL in, it'll bring up a page which will offer you this exclusive 30-day money-back guarantee with NordVPN as a Space Nuts listener. Now, you can have a bit of a look around at what they offer, and you can get all the information you need. They have over nearly 6,000 servers around the world, and they are high-speed servers, very reliable, and it does protect your online data, and it is the best encryption available at the moment. And it works on all sorts of devices. It works on iOS devices. It works on Android. It works on Windows. It works on MacBooks. You name it, it will give you protection on those devices and several platforms within those devices, from Google Chrome to Firefox to Microsoft Edge, etc. So you get great protection. So let's say you want to choose a plan. Click on the Choose Your Plan button. That's convenient, and it will give you the rundown on what's available in the various packages. Now, if you want to get the basic service, you can get secure high-speed VPN, malware protection, and a tracker and ad blocker, and that'll cost you a little bit less. But if you want to go for, say, the high end, you can get, on top of all that, the password manager, which I absolutely adore. I use that more than anything, to be honest, because if you've got to remember 100 passwords, and a lot of people have that many these days, it's almost impossible. So this manages your passwords securely. Very simple to use. There's a data breach scanner. You can get a terabyte of cloud storage and next generation file encryption for the entire package. Now, if you want to take it month by month, you can do that, or you can get a 1-year plan or a 2-year plan that brings the price down. In fact, if you go with a 2-year plan on the whole hog, it'll save you 69%, which is a pretty good saving. So have a look at it today, nordvpn.com/spacenuts. Have a look at what they offer, find what works for you, and give it a go. Don't forget, there's a 30-day money-back guarantee. That URL, again, for Space Nuts listeners is nordvpn.com/spacenuts. Get the deal today.
Did you miss your deadline to renew your Medicaid coverage? You can still send your completed annual review form to Healthy Connections Medicaid. You may be assigned to another health plan, but you can ask to come back to First Choice within 60 days of renewed Medicaid eligibility. It's your family. It's your choice. First Choice is the right choice. Renew and choose us. Visit selecthealthofsc.com/renew to learn more.
3, 2, 1.
Space Nuts.
Moving right along, Fred, let's talk dark. Excuse me. Sorry about that. I didn't mute my phone.
Oh, there you go. Actually, I did unmute my phone.
Oh, dear. Never mind. Now, let's move on to dark energy. And this is a fascinating story about how to possibly measure it. This is a new theory. When I say theory, we still don't know what it is. but we know it's there because it makes up, 68% of the known universe or something to that effect?
Yeah, that's right, the mass energy budget, because mass and energy are equivalent, that's correct.
So in lieu of the fact that we don't know what dark energy is, there may be a way of measuring it, and it involves our nearest neighbour, Andromeda.
Yeah, this story surprised me, and I kind of read through it a few times. I have not yet had time to look at the main research paper, which I'm just going to bring up now, just so I can see what it looks like. Yes, it's Astrophysical Journal Letters. This is big stuff.
Yep.
And the authors are from principally the University of Cambridge. The title of their research paper is Constraining Dark Energy from the Local Group Dynamics. And so local group is that group of probably 20 or so galaxies, which the biggest three are the Milky Way galaxy, the Andromeda galaxy, and something called M33, which is slightly smaller, but another lovely spiral galaxy. And the rest is sort of small stuff like the Large and Small Magellanic Clouds and a whole lot of dwarf galaxies. So what they are arriving at is extraordinary, logical leaps here. They're arriving at looking at the way these galaxies in the local group, and in particular the link between the Andromeda galaxy and the Milky Way galaxy, which, as you and I both know, are on a sort of collision course.
Yeah.
The way they behave, looking at them in detail, and to tease out evidence about dark energy. So, a quick recap: that you're right, absolutely right. 68% of the mass energy budget of the universe is this stuff, dark energy, which is making the universe expand ever more rapidly. We used to think the universe was probably actually collapsing rather than accelerating in its slowing down rather than accelerating in its expansion. But
you scared me for a minute there.
Collapse is not a good word when it comes to universes. No, sorry. I'll wipe that from my vocabulary. No more collapses. Pity, really, because you use it a lot in astrophysics. Anyway, never mind. The expansion of the universe was found to be accelerating back in 1998. It's a well-worn story. We know that Professor Brian Schmidt here in Australia played a major role in that and collected 1/3 of a Nobel Prize for it, which is brilliant. So, but the cause of that accelerated expansion is still a mystery, and it's been put down to dark energy, which is a nice term for something with no idea what it is. But we do know a little bit more about it now by very careful observations of galaxies and supernovae in the distant universe. So the distant universe has a big part to play in this. We believe that it is, whatever it is, it's always been there, and it doesn't change with time. And it mimics something that Einstein called the cosmological constant, which is why you see that referred to a lot in dark energy articles. And what it's saying is that if you've got a lump of space, it has its own energy. If that space gets bigger, so does its energy. The energy is absolutely linked to the volume of space you're talking about, rather than starting off with a lump of space that has no energy and then the energy comes along later. That's not what we think happened. We think that because it mimics the dynamics mimic the cosmological constant effect, what you've got is something where you 1 kilogram of space has a kilogram of dark energy, and or whatever it is. Anyway, the interesting slant on this new article is that we spend a lot of time looking deep into the universe to get the handle that we have on dark energy. And when you're looking deep into the universe, you are, by definition, looking at very faint objects. And that means the measurements are very hard, and the parameters that you get, particularly things like velocities or redshifts, as they really are for that, are a bit flaky. They've got quite high error bars. They're not as precise as you'd like them to be. So what these scientists are saying is, well, our galaxy and the Andromeda galaxy are likewise being attempting to be pushed apart because space itself is expanding by dark energy. That's part and parcel of what they have to do. Why don't we look precisely at the velocities of these objects and exactly how they're behaving to see if we can tease out something about dark energy? And I should just add, because otherwise we'll get lots of listener questions. Yes, the space between ourselves and the Andromeda Galaxy is expanding, but the Andromeda Galaxy is coming towards us because it's actually moving through space. Space is trying to carry it away, but its velocity towards us is great.
Yeah, so that should nullify the question. Hang on. How could it be getting closer if space is expanding? They're two totally different things.
That's right, yes. Yeah. So, so it's it is very interesting. The scientists are actually, I think, in applied mathematics departments rather than astronomy departments, which means that this paper probably has a lot of very hard mathematics in it. I haven't looked at the paper yet. I've only seen the abstract. The first author is Dr. David Benesty from the Department of Applied Mathematics and Theoretical Physics in the University of Cambridge. And so that's the bottom line, trying to check out the behavior of dark energy from the measurable behavior of two galaxies, one of which we're sitting in, and the other of which is our nearest large neighbor galaxy.
So what they're basically saying is if we analyze our own environment and look at what's happening with the merger of the two galaxies, we may be able to learn more about dark energy as a consequence of that because of the nature of this thing that we can't even define. The name's all wrong. We know that, but we don't know what it is. We just know it's there. We've known for nearly 40 years, I suppose, that it's there, and it answers a lot of questions as to why things are happening and how they're happening. I think. I know a lot of people struggle to get their heads around this, and I'm one of them. In fact, I'm probably bottom of the class when it comes to explaining these things. But dark energy, gravity pulls things together and dark energy pushes things apart. Is that how it's described?
So let's just go back through that one, Andrew. I lost you completely there.
Oh, okay.
You dropped out. So you're about to say...
something.
Yeah, no, it's one of the things we know about that.
Is it? Yeah, we can't define it because we don't know exactly what it is. In fact, we've got the name wrong.
Yeah, it should be.
Poorly describes what we're defining and puts people in the wrong frame of mind straight away. But the other thing is, I think I read that a good descriptor of dark energy is it's almost the opposite to gravity. Gravity brings things together. Dark energy pushes things apart. Is that fair?
It is in one way. It's fair. In exactly as you've said, it pushes things apart. Where it differs from gravity, Andrew, is that it's everywhere. Gravity is the only way you've got matter. Dark energy, you don't need anything. It's still there.
That's because it doesn't matter. Boom, boom.
I wish it didn't. On the other hand,
but unfortunately it does, given how much of it makes up the known universe.
Yes, indeed. So yes, it's look. I think this is work of the kind where you're looking at the potential for a new technique to give you answers about the nature of dark energy. I mean, what it's done so far, I think, is put upper bounds on the extent to which dark energy exists. It actually just sets limits. And that's a start. That's always a start in science, to have limits on what the range of a parameter can be that you're trying to find.
And the James Webb Telescope is going to be really focused heavily on this, and they're going to be able to measure Andromeda's mass and motion.
Yes,
which may, as you mentioned, those upper boundaries may help understand those more and perhaps come up with numbers that we can understand. But that new ESA telescope that they've put up there is also going to maybe try and solve this one as well. I think it's going to be focused on dark matter too, is it?
Yes, that's Euclid.
Yes, that's the one.
Yeah.
But as is quite often the case with stories we tell, we just leave people hanging because there's no answer.
The answer is probably 42.
Yeah,
but
that would be it.
Yeah,
indeed.
So we can at least, maybe we can put an upper bound on that and say, well, it's not 43.
No, but I'm guaranteeing that we'll get questions about this from all and sundry, because whenever we talk about this, and because we can't adequately answer the question, nobody can. It prompts all sorts of theories. I love the way people think when they come through with ideas about how this could be and what it might be, et cetera, et cetera. So I am looking forward to that, because I know it will spawn some questions.
That's good.
At the moment, they're looking at ways of trying to measure what's going on via the mass and motion of Andromeda. Would that be a fair?
Yes.
Sort of, draw a line under it there for now?
No, that's absolutely right. And you might want to point to the article I sent you for our listeners as well, just so that it was on Space Daily.
Yes, indeed. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Roger, you're loud and clear here also.
Space Nuts.
Yes, indeed. Now, Fred, let's go to some audience questions. And the first one is pretty bleak and dark, and it's going to make us all feel real good. This one comes from Nigel.
Hi, Space Nuts around the world. Hi, Fred and Andrew. This is Nigel from Brisbane in Australia. It's the end of the world, or so I've been told. Over the years, I've heard of different ways that the universe will wipe out life on Earth. The most common one is when the sun will expand and cook the Earth. Some of the other ones are, but I'm not sure about, another star will come into our solar system and we'll get hit with an energy burst from the pole of a supermassive black hole at the center of a galaxy. I'm kind of curious if there's an asteroid that's due to hit the Earth at a later date. Anyway, Fred, here's my question in two parts. One, can you give us a top 5 ways that the Earth will come to an end at the hands of the universe? And part 2 is, can you give us a time frame on each? I'm curious to know which one is going to come first. Love the show. Keep it up. Thank you, and see you later.
Thank you, Nigel. Very dark question, but also fascinating. The end of the world. I suppose we've been speculating about that since science fiction started being written. And, there are so many. I could think of 3 or 4, but 5, I don't know, 5? I think the most likely end of the world scenario, as far as human beings are concerned, is we'll probably destroy ourselves, whether that be through nuclear means or what. But that won't destroy the planet, but it will destroy us. That to me is a very likely scenario, given how we've been with each other for thousands of years. Asteroid, although there's nothing on the horizon, is there? The sun will eventually reach an age where it can't cope anymore and gets fat and old and destroys us. But let me throw one out there, Fred. Artificial intelligence.
Yeah, that's another. Now, Nigel did specify the end of the world at the hand of the universe. So
so
that means destroying ourselves
of the planet itself.
Well, no, I don't think he means that. I think he still means wiping out humanity, but by some cosmic cause rather than us doing it, which I think you're right is a potential, definitely it's definitely a doomsday scenario that we could effectively wipe ourselves out. But what would happen would be effectively the planet would become unlivable because there'd be so much stuff in the atmosphere, the nuclear winter, and a lot of radioactive isotopes spread around in dust. It would be a pretty nasty kind of scenario. The one that's it's a kind of on the edge of being a natural one and a terrestrial one or a cosmic one is a runaway virus. And we've seen what runaway viruses can do in recent years. I used to write about this as a potential end to humankind before COVID came along, and it definitely illustrated the veracity of what we were saying. That that's a potential end for humankind. Is if you have something that wipes out everybody, you're in big trouble. Then you're right, absolutely right. I think that the number one would be an asteroid impact. It's certainly not going to destroy the planet, but it doesn't take much of an asteroid impact to make the atmosphere unlivable again. Certainly something the size of the Chicxulub event back in 66 million years BC, BCE as it is now, before the Common Era. That was about 15 kilometres across. It's not much. Certainly, as far the Earth doesn't even notice that as a planet. Now maybe a slight glitch in the position of the rotation axis at the North Pole, but only by a few centimetres. So yes, that's but definitely for humankind really bad news. So we've got three there.
Supernova?
Yes, a supernova was where I was heading next. If there is a star we're pretty sure that there aren't any supernova progenitors anywhere in our neighbourhood. We talk about ones like Betelgeuse, 500 light years away or thereabouts, or Eta Carina, which is 8,000 light years away. These are their effect. Whilst probably not benign, it's not planet killing effect. So the other one, I guess Nigel's right in thinking about if you've got beamed radiation, which does come from the poles of black holes, and it's in our direction, that could be problematic. It may be, the galaxy, our galaxy, the black hole at the centre of our galaxy is pretty benign at the moment. If it woke up and started chewing up a lot of stuff, then that could start spraying out a lot of radiation, which might not be very pleasant.
Gee whiz. That's nice to know. Could something come in from outside of our solar system and sort of sweep away our protective cocoon?
Well, so Nigel mentions a star straying into the solar system. There's certainly nothing at all on our horizon that would fit that bill, not even brown dwarfs, which are quite hard to observe. Because all the ones we can see, you can measure what their velocity is, and they're just standard velocities. But maybe an interstellar asteroid. I don't know that it would be any more dangerous than a solar system asteroid strike. They are going faster. It could be going at 60 kilometers per second, and that means it releases a huge lot more energy on the Earth when it hits it. Even your favourite space object, Oumuamua, had it hit the Earth, it would, 400 metres or something long, or in diameter, depending on what shape you think it is. That's going to do some serious damage. So And that came out of nowhere. That was one that we didn't see coming.
Well, we didn't see it till it had gone past.
Gone past, yes, that's right. Yep.
Yeah, that's scary. So, Nigel, all sorts of possibilities, but none that we are aware of at the moment, especially with the asteroid question. I don't think there's anything within 100 years, is there?
That's right. No, not within it. PHAs, potentially hazardous asteroids, of which there are some thousand known now. I think it's about 2,000 or 3,000, if I remember rightly. None on a collision course within the next 100 years.
That's good news. You can take a breath, Nigel.
For 100 years, anyway.
For 100 years. It's all good. But no, great question. We love speculating from time to time, and it's nice to get a what-if question, so thank you for that. Let's move on to our next question from Noah.
Hi, Fred. Hi, Andrew. It's Noah calling from Eureka, California. We land at the pointy end of the Cascadian subduction zone, close to the other side of the globe from you guys. So my question is a two-parter with a bonus question, and it has to do with light. So I'm a mechanic, and sometimes to trace the source of a fluid leak, I'll add a special dye to the engine or a transmission or air conditioner. Then, using a UV lamp and yellow glasses, I illuminate the area with the leak with UV light. The dye I added glows eerily and stands out visually, enabling me to trace the source of the leak easily. So part A of my question is this. How can I see the UV dye through my yellow goggles if my eye cannot process UV radiation? What am I actually seeing? Is the spectrum shifted downwards somehow? Part B of my question is this how UV-sensitive telescopes and craft like MAVEN work? And here's the bonus question. Why does the light appear spooky yellow or green or red, depending on the dye that I'm using, if the UV is on the violet end of the spectrum? Shouldn't the dye look violet? Thanks, guys. I tend to think of a lot of weird stuff like this at work, and this one has been puzzling me for a while. Thank you.
Thank you very much, Noah. Wow. So he uses a dye to trace a leak in an engine, and I'm gathering he wears goggles to look at where the dye has travelled, but he's wondering how that works when you're not supposed to be able to see UV.
Yep.
So what's
just remind me, Andrew. Noah uses a UV light source. Is that right?
I guess he uses those night vision goggles. Would they use UV? That would use
the light source itself.
Yeah.
No, it's all right. I just wanted to check. So
okay.
What I think is happening is you've got a leak, and you want to check that the fluid you poured in at one end is coming out the other. Our plumber does it, the same thing, actually.
Right.
It's how he worked out where our storm drains come out.
Okay.
Because of a fluorescent dye. Except it's probably not quite as high-tech as what Noah's using. But So certain materials, I think I've lost you again. Oh, I got you back. Let me repeat that. Certain materials, when they're illuminated by ultraviolet light, the ultraviolet light is high energy light, and so it excites them to fluoresce. And so they fluoresce, they glow brightly by this process, which is in a completely different waveband. And yes, often it's yellowish. So what you're seeing there is some sort of molecule that gets kicked by an ultraviolet photon, and that it puts it in an excited state. And then when it relaxes again, it emits a visible light photon, which is fluorescent. So it's how, and in fact, that process is used a lot in technology. It's how, when the first charge-coupled devices, which are the image sensors that are related to what's in your phone and your camera, when we started using those in astronomy, they were only red sensitive. But to make them blue sensitive, what we did was coat them with a fluorescent material. so that when ultraviolet or blue light hits it, that material fluoresces, and the chip itself, the silica chip, is sensitive to red light, so it picks up what that fluorescence. And so what you've got is a kind of proxy way of measuring the ultraviolet light. And it's extremely, it worked very, very well. So coated CCDs, coated by some sort of fluorescent material, were very much the way of doing things when I started off in this sort of technology back in the 80s.
So you may have answered part C of his question in answering part A, because he was wondering why he sees this fluid in yellow, green and red when he thinks it should be violet, but it's possibly because of that process you were explaining.
Because the photons are being re-emitted at different frequencies. Yeah.
Okay. Glad we bumped off two parts in one go.
There was another, wasn't there a gift?
He was asking about, is this the way UV telescopes work?
In that regard, as I've just said, yes, it is. That's how a UV sensor might work. These days, there are better ways of doing it. You actually back illuminate the CCD. You make it thin enough on its substrate that you can illuminate it from behind, and that improves the ultraviolet sensitivity. That's basically how one way of doing it, to have a fluorescent coating, and the other way is to thin them, what we call thin CCDs.
There you go, Noah. It's all about excitement.
Yes, it is. Just like
molecular level.
Space nuts, isn't?
Dear. Thanks for the question. Really interesting. My brain works the same way as yours, Noah. I find when I'm doing things, my brain just goes somewhere and starts asking, how does that work, or why is that happening, or why did I get out of bed this morning? It just all sorts of. I'm always sort of my brain won't stop. It just never stops. I often wake up at 3 or 4 in the morning and can't get back to sleep because I need to figure something out. It's bizarre. Don't like it much sometimes. Thanks, Noah. And one final question from Anne.
Hello, this is Anne from Bellevue, Washington. I have a question for Women Astronomer Day. Can you explain Vera Rubin's contribution to the discovery of dark matter? Thank you very much. I appreciate your podcast.
Thank you, Anne. Lovely to hear from you. And we have spoken of Vera Rubin in the past. And of course, the Vera Rubin telescope is at the forefront at the moment, or will be soon. But yeah, it's a good question.
It's great. And Vera is one of the most noteworthy American astronomers of all time. She has an extraordinary life story. She was keen on astronomy as a girl. I think she built her own telescope when she was still just a youngster. I can't remember where she grew up, sadly. And then went for an astronomical career, fiercely dependent of women's rights in places like observatories, which were highly male-dominated. There is a story that might be apocryphal, but I like it very much, about one observatory that she went to, one telescope she went to, where there were no toilet facilities for women. And so she took over the gents, and where there had been the usual sign for the male toilet is a sort of figure, she put a triangle on it to give it a dress, so that it was the standard sign for a female. And a great champion of women in astronomy and fantastic stuff. She won my heart back in probably 2004, because she wrote a really nice review of Stargazer, my first proper book about the history of the telescope. It was in Science magazine. She said some very kind things about it, so I was always very, very fond of Vera in that regard. Her contribution to dark matter is one that, once again, it's really quite subtle, because the dark matter was really known about back in 1933, when Fritz Zwicky, a Swiss-American astronomer, realized that a cluster of galaxies he was looking at, what's called the Coma cluster, it's in Coma Berenices, a northern hemisphere constellation. That cluster had galaxies in it that were moving too fast to be part of the cluster. They should have just flown away gazillions of years ago. And so he said that, the material that he could see and detect was not enough to hold the cluster together, and therefore suspected that some kind of dark matter existed within the cluster, which was unknown. And the astronomy world at the time basically ignored it because it's just too hard. What does that mean? But it was when Vera did measures of the rotation of galaxies in the 1970s, particularly galaxies like the Andromeda Galaxy, which is near enough that you can't quite look at, or you couldn't then look at individual stars in it, but you could take spectra, rainbow spectra, to measure the velocity. Andromeda's almost edge on to us. It's tilted, but almost edge on. And so you've got, because we can measure very accurately what we call the radial velocity, the line of sight velocity, since it's rotating and it's almost edge on, you get really good measures of those velocities on either side of the center of the galaxy. And she extended it, not just using stars, but also using clouds of gas with radio telescopes. And what she realized was that the way the galaxy was rotating, it must be enveloped in a cocoon of something that was allowing it not to fall to pieces, because the velocities, rather than behaving as they would have done if all you could see was all that there was, they were behaving in quite a different way. It's what's called a flat rotation curve. So that was the big breakthrough, and at last people started taking note of it in 1978. She and one of her colleagues who built the instrument that they used to make these measurements scored a major hit with the paper. And sadly, we lost her. If I remember rightly, it was Christmas Day 2016 when Vera died.
Yeah, it was a sad thing because she was such a pioneer and achieved so much. She was born in Philadelphia, by the way, and lived in Washington, D.C.
Yep.
So up in that northeast
northern
part of the United States. But I'm glad the question came in, Anne. Thank you so much for doing that. We do like to hear from our female listeners, but we also like to share some of the great successes by female astronomers and space scientists, and there are starting to be more and more of them now. Some of those big barriers have been broken down, and Vera Rubin, one of the people that made that possible, I think.
Mm-hmm.
Thanks, Anne. Lovely to hear from you. Thanks to everyone who contributed. And a reminder again, if you do have questions for us, you can send them through via our website, spacenutspodcast.com, and just click on the AMA link at the top, or send us your voice message on the right-hand side. You can use any device with a microphone. Use one of these, an iPad, or one of these, an iPhone, or anything that's got a microphone. You can send us a voice message. You can write it down on a piece of paper and scan it and send it through to us as well. That's okay. All our contact details are on the website. And have a look around while you're there. There might actually be a Space Nuts shop on our website, which you can buy little goodies, get yourself a sticker or a cap or a shirt or a hoodie. Next time you're robbing a bank, you might think of us. Now... Dear, where'd that come from? Let's wrap it up. Fred, thank you so much.
It's a pleasure, Andrew. As always.
Sometimes.
I'm just trying to imagine whether any of our listeners might be bank robbers. It's not something that's ever occurred to me before.
Well, if they do and they're wearing a Space Nuts hoodie, that's probably going to be it'll narrow down the suspects.
Yeah, that's right. It will.
Okay. Thanks, Fred. We'll catch you real soon.
Sounds great. Take care.
All right.
Andrew.
Professor Fred Watson, astronomer at large, part of the team here at Space Nuts, and thanks to Hugh in the studio for just being him. And from me, Andrew Dunkley, we'll catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.